Each one of us is holding a smartphone today, right? And normally, when we go for shopping to buy a smartphone, among all the features, there are few obvious features which we look for, like the processor and the memory space. The similar thing applies for laptops as well. We look for the quality of the processor. Now, why this is important? This is necessary because it helps to decide the performance as well as the sustainability of the system for the next few years. The other few features which we look in a smartphone could be camera quality, the image quality, the resolution, and of course, how many number of features that smartphone can accommodate. Now, all these are nothing but the different facets of semiconductor innovation, and VLSI is the primary technology which is responsible for it. VLSI, in simple terms, refers to very large scale integration, which means integrating or embedding billions of transistors into a single chip to form an integrated circuit. And in the process of doing so, we need to take care of three parameters, which are also called as the three pillars of VLSI industry. That is the power, speed, and area. The power consumption of any device should be as low as possible, the area requirement should be optimal, and the speed should be faster. Now, as you can see from the slide, there are multiple different technologies emerged before VLSI, like SSI, MSI, and LSI, which stands for small scale integration, large scale integration, and medium scale integration, which are different transistor counts. But VLSI is the only technology which brings maximum amount of innovation, and the reason for that, it has the capacity to accommodate more number of transistors into a single chip, maybe more than millions. Not only the type of transistor or the amount of transistor, the type of transistor is also a critical factor while deciding the chip or the product to be shipped into the market. And that's why MOSFET is a preferred choice among all the other conventional transistors, and the reason for that is power consumption is lower as compared to the previous generation of transistors. Nowadays, while chip fabrication, FinFETs are also used because of its lower leakage current as compared to the MOSFET. Not only in the field of like smartphone or laptops, as I mentioned earlier, VLSI provides numerous series of innovation over the past few decades in the form of or in the field of graphics processing unit, central processing unit, memories, computing unit, servers, and even in the automotive sector when you are looking for ADAS or the new technology in the cars. So basically, but here is a question or kind of a problem statement that we all know that the innovation or like kind of say like the unique ideas occur at the intersection point of multiple different technologies. So there should be some other technologies that can boost the impact of semiconductor. So the answer to this question lies in the Industrial Revolution 4.0 or 5.0, which are basically governed by cyber physical systems. That means our routine and boring tasks should be performed by the machines, and the complex tasks should be performed by the humans. And for that, we require continuous collaboration between the humans and the machines. In short words, it promotes automation. In this process of automation, the machines become intelligent enough so that they can interact with the other machines, tries to detect their faults, and even rectify them. So, because of this, there are multiple different technologies that comprises of this Industrial Revolution 4.0 and 5.0. So, some of them are like big data, then data analytics, embedded systems, and then you have IoT and machine learning, AI, and even blockchain. But there are primarily two technologies emerged out as winners, which has the potential to change the world and open the doors of future revolution. These are AI and blockchain, which combinedly form Web 4.0. Now, before I dig deep into Web 4.0, we need to know what are the different divisions of web technologies and how we came to the innovation of Web 4.0. So basically, let's go back into the year of 1990s. In in that particular year or in that era, a user can only be able to interact with a web page in the form of a view or reading. That person doesn't have the capability to interact with the web page. That means that person has only the reading ability. So that page is called as a web 1.0 or a reading page. After that, social media boom came, and then we have like several apps and websites like Facebook, LinkedIn, YouTube, where a user can interact with that web page in the form of likes, comments, and shares. So that means that person has both reading and writing ability. So that era is termed as Web 2.0. After that, a completely new web technology arrived, which changed the landscape of web technology because it able to address the problem which Web 1.0 and Web 2.0 are unable to solve, and that is called as a ownership. With Web 3.0, each entity over the internet has their own ownership, and that is only possible because of its decentralized nature and the back of the concept of blockchain. And due to that decentralized nature and peer-to-peer network, blockchain, or so to say Web 3.0, has already impacted multiple different industries. Like cross-border payments have become eased out or smooth between the sender and the receiver because there are no intermediaries involved or no central authority monitoring the transaction. Moreover, the supply chain management has also been impacted or so to say improved due to the traceability and the transparent nature of the blockchain, so that each record can be tracked from the source to destination. Real estate sector is also impacted because of the introduction of the smart contracts. Smart contract is nothing but a self-executing code which is running on the blockchain, and once it got pushed into the blockchain, no one can modify it. Due to that, both the kind of tenant and the owner has to abide by the rules of the smart contract and need to follow them. Healthcare is also slowly getting impacted because the patient records can be stored in a decentralized nature, and obviously the confidentiality can be provided with so to say permission or a private blockchain. After that, the carbon footprints are also getting reduced due to the impact of blockchain, so that each record can be tracked, and nowadays we use the word called as a carbon negative, which has been used in the positive sense. The legal cases are getting fast tracked because of this, and one of the practical example is Aragon Court of Zurich, which has already implemented it, and due to the number of jurors are there, who can vote in the form of a consensus mechanism, so that all the users and the members of that DAO, that is decentralized autonomous organization, can vote and make the case fast track as compared to the traditional approaches. So after this, Web 3.0, obviously we have Web 4.0, which comprises of AI and blockchain. And in spite of all the advantages and of this Web 3.0, Web 2.0 has the capacity or the potential to open the doors of multiple innovation in conjunction with the semiconductor. So the first part of Web 4.0, as I mentioned, is AI. So as a real engineer, we need to be ensured when a product is shipped onto the market, there are no silicon bugs in the design. Because a single bug not only delays the entire project execution life cycle, but also cost a company millions of rupees. And it might also be possible that the product not even shipped onto the market. Due to this, we need to code rigorous test scenarios and multiple use cases to check there are no bugs in the design, which obviously requires coding effort, debug effort, and meeting the time to market within the stipulated time. So doing all these things manually becomes cumbersome at time because the time to market is shrinking day by day. So because of this, here AI can help. With the help of machine learning, we can train a model with a large number of data sets, which has the capacity to anticipate some of the corner case scenarios where the bugs can be sitting, or we can unearth new bugs with the help of different ML techniques. Nowadays, the EDA vendors are coming up with new technologies into their tools in which the ML-based engines are already inbuilt. so that the flows can be automated, the bugs can be unearthed quickly, and the time to market can be smooth enough so that the product can be shipped onto the market quickly. Convolutional neural network and the recurrent neural network are two promising areas of research in the field of image signal processing, which are already affecting the semiconductor. Moreover, like the pattern layout, in analog layout we need to design various patterns, how the chip looks like, what are the different mixing rules. All these things are being taken care by the different ML techniques. The other aspect of Web 4.0 I mentioned is blockchain. So with the introduction of blockchain, multiple different engineers can work parallelly at the same time without being dependent on some other engineers who can push the code into the central repository with some revision control systems. Although revision control systems are necessary, but with the help of the blockchain, the transparency is there and multiple different engineers can work concurrently at the same time. The other advantage is that with the introduction of different test scenarios, sometimes it's been observed that the server space is overloaded due to cluttered data and unwanted logs. So some of these problems can be reduced with the help of the blockchain because the lesser complex test cases can be verified at the P2P network with the integration of the smart contracts into the third-party code. So these are the different ways through which AI and blockchain has already boosted the impact of semiconductor. Now the thing is that there is a use case scenario which remains for the future. With the rise of AI, LLMs and ChatGPTs, the day is not that far when AI becomes expensive and it might not able to reach the common people and it might be subscription based as well. In those cases, blockchain again can help because it has the power to democratize AI and make sure that it can reach the common people. Last but not the least, I want to end the talk with a simple thought. There are multiple technologies out there, like AI and blockchain, and some might evolve even after them. But the most important point here is that how to connect the dots and integrate the existing technologies with the new ones so that it can open the door for the future innovation and make this world a much more better place to live. Thank you.